The next speaker is Clement. He's building electronics for fun and profit and has been teaching electronic skills at various community events for the past decades. He contributes to KiCad, thanks for doing that, and is talking about how to do electronics oneself. Many thanks.
Hello everyone, and thank you for being here. I didn't expect them to put me in this room, so it's a bit terrifying. Okay, yeah, so I build the electronics for a living, and my job is to take ideas and turn them into prototypes, and sometimes into products. And I also teach electronic skills at community events like this one. So I've seen many people who want to get into electronics, but they either don't know what steps to take, or they think they can't do it. Lots of people think building hardware is hard. I don't blame them, because hardware is hard is a bit of a meme. And this meme is a bit misleading, because it's actually about businesses that are based on manufacturing hardware rather than hardware itself. But it's a meme. It comes without context and spreads itself as a memorable soundbite, infecting minds. And I'm so tired of this meme. Hardware is not hard. It can be trivial or incredibly complex, depending on what you're building, but it's not some arcane dark art. It requires some knowledge and some skills, and those can be acquired with reasonable effort. That doesn't mean you can start from zero and immediately build anything, but it means you can start from zero and build something, and then learn from that and skill up slightly, and then build more things. Learning to build and understand electronics will change you. You start to look at things differently. You start imagining solutions to problems you have and devices that work for you rather than against you. Sometimes you build them. You look at things that don't work quite how you want them and repair them and hack them and improve them. And you open things up and start to recognize patterns about how they're built and how they do what they do. I want more people to have this feeling. So what I want to do in this talk, I want to sing the praises of the electronics field and tell you what incredible resources are available to make building electronics delightful. And then complain some about what the field currently looks like socially. I'll explain why I think everybody who is patient and motivated can get into electronics, regardless of their background, and suggest some gentle ways to get started. I'm not going to go into lots of technical details. I want to give you an impression of what it's like. Doing electronics used to be much harder. I've been doing this since I was a teenager, and well, I'm very far past being a teenager now, and so much has changed. Not all of these things are new. Some have been there for decades. But I want to point out some things that people from outside the field are not necessarily aware of. And if you don't know about them, it all seems much harder than it is. There's this enormous support services infrastructure that is built around electronics to make our lives easier. This includes component manufacturing and distribution, circuit board manufacturing, automated assembly. These things are optimized to the hilt and yet keep getting better and better and cheaper and more accessible. The prices for everything have gone down an order of magnitude or more within the last 2 decades. It's honestly quite incredible. And at the same time, PCB design software has gotten dramatically more accessible and easier to use. And access to information resources has also become incredibly easy. So let's look at these things in a bit more detail. You can obtain modular electronics and connect them together with jumper wires or a so-called breadboard. You can't do this for everything, but there's a wide variety of microcontroller development kits and sensor breakouts and evaluation modules, and they're ready to use modular PCBs for battery management, for screens, for power conversion, all sorts of things. You can buy these fairly cheaply, plug them together, and very quickly figure out how to get your things to work. So you get a really rapid result with very little effort. These are not necessarily open hardware, but often come with enough documentation that you can reasonably do some design reuse based on them. These, the rough circuit and part numbers, are generally easy to figure out. And some of them are really well documented, and they're open hardware, and they provide direct resources for learning. So there's some bigger names to look out for this area, like Adafruit, SparkFun, Arduino, but there are others. So you can get pretty far with just plugging things together. And then if you want to take it to a slightly higher level, you can start working with components directly. So in electronics, there's a lot of problems that need to be solved again and again and again. And some of them are kind of difficult to get right and verify. So there's this semiconductor manufacturing industry that's taken this challenge on and mostly won. Instead of constructing a circuit from scratch and verifying it works in every new design, it makes sense to reuse designs. And an enormous industry with thousands of vendors and millions of parts has built itself up around this. They come up with things that lots of designs can make use of, and then construct a packaged up, ready-made component to do it that you can then buy and add to your design. And they have enormous, phenomenal economies of scale. The result of this is you can get lots of complex functionality, advanced sensors, microcontrollers, interface converters, power management, and all of this for ridiculously low prices. You can get a battery management IC for single-digit cents at quantity. Most of these parts are made on older manufacturing nodes, so they don't suffer as much from the intense competition for manufacturing capacity that drives up costs. This makes these parts really cheap and plentiful. Lots of things that were very hard to do well are now basically solved problems that you can just plop onto your design with relatively small effort. And the number of things that are solved problems keeps growing. Not too many years back, it would have been an enormous undertaking to get Wi-Fi into a beginner project. Now it's as simple as taking a part that costs single-digit euros and putting it into your circuit. And this is the case for many, many, many things. So by exploiting this huge ecosystem, you can skip a lot of the difficult aspects of a project because someone has done the heavy lifting for you. This and the wider electronics component industry have used the power of volume manufacturing and automation to drive down the cost of parts to absolutely ridiculous levels. Many components are priced in fractions of a cent. There's thousands of highly specialized manufacturers that churn out enormous volumes of specific parts and still manage to keep operating with margins of single-digit euros per 10,000 parts. There's millions and millions of parts you can use. Now, this can feel pretty overwhelming, especially if you need to sort through and have interactions with so many different companies. However, there's an abstraction layer built around these component companies, and that's part distributors. They work out arrangements with many manufacturers and then provide parts in smaller quantities for anyone who needs them for a slightly higher but still incredibly low cost. This means instead of getting parts from many different specialized vendors, you can buy in a handful of places and have them collect and bundle them for you. And this is awesome, as no part manufacturer is usually willing to sell you one of something. Because of the large economies of scale, even with distributor markup, most parts are unbelievably cheap. Distributors also have another important function. They have searchable digital catalogs of part information. This is awesome for finding and comparing parts, as the search functions are parametric, so you can select values or ranges of values for specific parameters and get lists of matching parts. And this works across vendors as well. Distributor websites are also a very easy way to get documentation on parts. They usually either mirror or link to so-called datasheets for each part, which is the main form of documentation. I've listed a few component distributors here that I frequently use and a couple more that exist. I won't have time to go into the differences between them, but this is a pointer for you to look into. And then we have PCB manufacturing. Now, PCB manufacturing is an incredible thing. So most modern electronics consist of parts soldered to circuit boards. And a circuit board is a precision-manufactured sandwich of fiberglass and copper with many interconnected layers of copper formed into super precise patterns. The feature sizes of this are measured in fractions of a millimeter. And unlike components, which are mass manufactured, all of them the same, PCBs are actually custom-made for each user. Circuit board manufacturing is an incredible example of manufacturing engineering commercialized into a commodity. You can get incredible manufacturing technology made just for you, based on your own design, for single-digit euros per unit. And it can be made on a time scale of days. And it can scale to thousands of units. This is really remarkable. And most things that operate on the same scale are either much more expensive or much less precise. PCB designs are almost like software now. You have a wide choice of vendors, you send them a file, and you get functionally exactly what you designed back a few days later, regardless which vendor it is. Of course, there's differences in location, pricing, and capabilities, but it's absolutely amazing that this is even possible. Now, not to go all back in my day, we walked uphill both ways, but within the span of my career as an electronics designer, this service has gone down in price by an order of magnitude while improving capabilities. The threshold to a custom PCB is so much lower than it's ever been. I've put a few vendors on here I've had interactions with. There are many, many, many more. As they all use the same data format, you can shop around and easily switch, so you're not stuck with a vendor once you go with one. Then we have PCB design software. Now, most PCB designs are drawn in specialized software, and PCB design software has gotten pretty amazing. The development in the last decade has been phenomenal. Software cost and capability is basically no longer a barrier for anybody who wants to get into electronics. And so much has happened there, but the summary is free, liberal, open source software has basically eaten this space. And you can get software that will do what you need for free, developed in the open, with a community around it. I and many others help out with a software package called KiCad. And this is now the most popular PCB design software in the world. And yeah, that's quite a change. That definitely didn't look like that a few years ago. Yeah, it comes with a big library of parts, and it's enough for pretty much anything you want to design. I want to mention two other open source packages here that I'm not very involved with, but they're awesome people who make wonderful tools, and they don't get nearly enough mention. There's a number of commercial packages as well, but they're not really worth mentioning. And I'll get hate mail for this, but there is no future in any software package that holds your designs hostage. So, next thing we have is published projects to learn from. There's an enormous number of hardware projects in digital form that people have published online. And some of them are officially open hardware, some are not, but still put their documentation somewhere where people can see them. And you can search source repositories for a part number and find projects that use it. This is an incredible resource. And both the quantity and quality of published projects has dramatically improved in recent years. One of the best places to learn things is to take apart an existing working thing, dig into it, and really figure out how it works. This is so much easier now that people show their work and sometimes even tell you about it. You can find many of these by searching your favorite repository forge for part numbers. There are companies from within the community that build open hardware with a focus on learning and document them incredibly well, and they also publish their designs. Now, there's plenty of free sources available. I could go on and on about this. I don't have that much time, but yeah, test equipment is cheaper and more accessible. Embedded software and tool chains are getting easier and more open, more beginner-friendly. So much is happening. We have embedded Rust now. We have MicroPython. These things are a major change in how accessible software development in embedded is. And I see more people getting into hardware, which is great, but it's not enough. I believe, everybody can acquire the skills to build hardware. And here's why. One of the most powerful techniques in electronics manufacturing is reflow soldering. Back in the old days when I was a kid, electronic components all came with bits of metal sticking out, going through holes in the circuit board, and connected with individual blobs of solder. And those are simple enough, but relatively high effort to assemble. The industry has since mostly switched to something called surface mount technology. And surface mount parts get assembled differently. Instead of holes, you have a pattern of copper on the PCB that the part sits on, and you apply solder paste in that same pattern using a stencil. Then you place all the parts on and heat up the whole board at once, and everything gets soldered at the same time. This enables smaller parts, bunching them up much closer together, and assembling things much faster in a more automated way. Now, the same process can be done by hand with very minimal equipment and just a tiny bit of practice. Most PCB manufacturers will do this assembly for you, but it's much cheaper and faster to do it yourself by hand if you're only assembling a few boards. Maybe people don't know this, but it takes a full day to program and prepare a pick-and-place machine for any moderately sized project. But you can build a handful of boards by hand in just a couple hours. Now, 10 years ago, someone was wrong on the internet. They were telling people on a forum somewhere that you can't work with surface mount parts without expensive specialized equipment, and in fact some SMD parts were impossible to assemble by hand at all and needed machine assembly. This is bullshit. It was then, it is now. I knew this because I was doing hand assembly of surface mount parts regularly, so I figured I'd prove a point and get people who have never touched electronics before to do some surface mount assembly. So I designed the board, I had some made, I called some friends, Ruben and Harald, who I think are in the audience even, and asked them if they wanted to come to the next event that seemed suitable with me and help out with teaching a workshop. And that happened to be a maker fair in Rome. We had no idea what we were doing. I set things up in the worst possible way as an assembly line style setup, so people had to move around with partially assembled boards. We were doing reflow soldering on a kitchen hot plate next to a window of a university lecture room, hoping the fire alarm didn't go off, and picking and placing parts with tweezers. But every single person successfully assembled the board. People who had never touched electronics before. People who didn't know what a PCB or a soldering iron looked like. One person had extremely poor vision, had his daughter next to him, telling him which way to move the parts so it aligned in the right place. That board worked too. Every single one did. And Ruben was interviewing people at the end of the line, and one of them delivered a line which stuck with me. I was waiting for the hard part to come, and then I was done, and it never did. So I ended up teaching similar workshops with somewhat better planning at various community events over the next decade, including every Congress since 2015. Lots of people wanted to do them. At one particularly misguided Congress, I ended up doing 10 sessions, and they all filled up. And by now, I've taught thousands of people this technique. And with single-digit exceptions, like people running off in the middle of the workshop, every single one successfully assembled a working board. And I've been upgrading this over the years, and like the current ones have parts that are considered the most difficult to handle in the industry. And we're still putting them on by hand. And every single board works. Now, a couple years in, someone tapped me on the shoulder after a workshop and went, "Oh, hey, thank you for still doing this workshop. I did it a couple of years ago." I was about to go, "Yeah, thanks, no problem," or something like that. But they continued and told me, "Hey, you changed my life. I quit my job. I started a company doing electronics." I was not emotionally prepared for this. I'm still not emotionally prepared for this. I was just trying to prove someone wrong on the internet. And I've got similar stories multiple times since, of people telling me that just learning this one technique set them on a path into electronics they hadn't dared to take. So what is this supposedly life-changing technique I've been teaching? It's reflow soldering done the exact same way it's done in the industry, with the minimum viable setup, stupidly simple hand stabilization trick. There's nothing special about it. I'll explain to you in literally 3 minutes. Instead of soldering each component onto a board individually, use a stencil. A stencil is a piece of steel with holes laser cut into it where your solder connections go. You can get it from all the same places that make PCBs. You fix the stencil on your PCB, use a flat tool of some kind to screen print solder paste onto the spots that need to be soldered. Solder paste is solder ground into little balls mixed with a substance called flux. This makes it semi-liquid, gooey enough to print, but still able to hold its shape on the pads. Then you remove the stencil, and you have paste only on the spots where the components will go. You then take tweezers and pick up parts and plop them onto the paste. You can adjust and correct this for hours if you like. And when you're done, you heat up the whole thing. You can do this on a totally normal household hot plate, or you can do it in a really fancy reflow oven. All the solder melts, and as it melts, the flux makes the melting solder balls form separate blobs for each contact that don't touch each other. And this is awesome, as you don't need to solder everything individually. And if some of the contacts do accidentally short, you can add more flux, reheat that bit with a soldering iron, and they will separate. And then there's the hand stabilization trick. Turns out, if you touch a solid object that's close to the thing you're working with when picking and placing a part, your hand doesn't shake nearly as much. This is a technique that's been known to painters for centuries. They rest their hand on a stick that's leaning on the canvas for better precision. You don't have to be a painter to do it, just like you don't have to be a pick-and-place machine to assemble parts. Doing a couple of boards by hand is way, way, way faster than programming a machine to assemble it for you. And it's obviously cheaper, and you don't need the machine. And this is basically it. This process is super forgiving because machines have to do it at high speed. And machines will mess up all the time and not even notice. So it has to be forgiving. It's super easy to do by hand when you have more time and the ability to correct things. There's nothing special about any of this. Maybe new and unfamiliar, but it's not some arcane, inaccessible knowledge that nobody knows about. And this is one of the most advanced assembly techniques, and it's this easy to learn. The only special thing is the kind of people who show up. All sorts of people come to these workshops. All ages, all genders, all nationalities, all kinds of educational backgrounds. They are a cross-section of the people going to these events. The electronics industry itself looks nothing like that. At industry conferences, none of that diversity is there. Non-male visitors at such event are single-digit %. Very few come from any educational background other than electrical engineering. Even at the most diverse community conferences related to electronics these days, it's overwhelmingly white male, at least in the West. It's dramatically, dramatically worse than even software, which is already pretty bad. Why does this enormous diversity of clearly interested and motivated people show up at some random person's workshop at Congress and not in the wider industry? Yeah. I think you know the answer. But yeah, what's the issue? People try things, they get stuck, they ask for help. And there's a bit of culture in engineering that you tell people when they've done something wrong, which is fine. The problem is an experienced practitioner has a very different definition of wrong than a beginner. When we do a design review, we can always think of something to do different, something to do better in our minds, even when these things are not really an issue. And this feels absolutely terrible for someone with little confidence starting out. And many places where they can ask for help turn toxic. You have people who have been on the forum for years, they make newbies feel like newbies, the newbies leave. Other people see this, they don't even bother trying. They go and ask an LLM instead. The LLMs have no idea what they're doing, they're friendly but give absolutely terrible advice, people follow that advice and fail. They decide the whole field is like that, and culturally it often is, and they never get into it. So why is it different at a Congress workshop? Because a workshop like that is an entry point which specifically gives people with no experience permission to participate, make mistakes, and build confidence in what they do. And that kind of thing is fairly rare, and it really doesn't have to be. Like, the electronics industry should be doing this. It shouldn't be like left to places like this to make up for their failure. Now, what can we do about this? We can give people more space to do their own thing. When they ask for help or advice, we don't overcorrect them. And I've made this mistake myself many, many times as well. It's a really strong impulse to both share what you know and prevent others from walking into a trap. But in many cases, it's too much. And it's possible to give advice without trying to make decisions for the person. Because after all, they're trying to learn something. Somebody asked me recently, how do I go from being an electronics hobbyist to being an electronics professional? And I answered, this is the wrong question. Hobbyist versus professional is a question of motivation. Are you doing something for fun? Or are you doing it to get a result? And motivation has nothing to do with quality or skill level. You see hobby projects that are of much higher complexity and quality than the median commercial electronic product. And there's things made by highly paid professionals that are honestly shameful. What I find much more useful as a question is, how far do you want to take this project? All electronics projects lie on a continuum from idea to prototype to product to e-waste. And some projects never make it past the idea or prototype stage, and that's okay. And this happens quite a lot in the professional world as well. A project that is not taken to the next stage is not necessarily a failure. Many things exist only to see if they could actually work. And we as an industry need to accept that the distinction between a hobbyist and a professional is absolutely bogus because we're missing out on some awesome people this way. I personally almost missed out on this. I never had a formal education in electronics. My formal education is in computer stuff. I started doing electronics as a hobby in late teenagerdom. And I had a handful of completely misguided projects and a few limited successes, and then went into the real world, doing real-world computer stuff like I was meant to. And it took me too many years to realize that electronics is where I'm happiest. So I got back into it. I learned a lot more. I started doing it professionally. And with every project, I gained a bit more skills and a bit more knowledge. I built my first of many, many things. And it was terrifying every time. My first safety-critical device, my first high-power device, my first live mains voltage device, first medical device, first high-speed layout, first security-relevant device, etc. By now, I've built many things. A number have been mass-produced. I know for a fact there are some people in this room using things I've built. And you can get there too. Every single one of you can get there too if you want to. It's up to you how far you take it. It looks overwhelming, but it's really, really not. And each step builds you up for the next one. You can do this, and I really hope you will, because it is life-changing. So you should do this. And sometimes the hard bit never comes. Thank you.
Dear Clement, many, many thanks for the great talk. So, regarding questions, anybody got a question? Okay, nobody on the microphones? Someone? Yeah, great. Number 4.
You mentioned that KiCad has great libraries. I found this to be true. But when I found something that was missing there, or that was slightly wrong for this particular component, I found it very hard to get anything reasonable without drawing it myself. What's your solution to the problem of KiCad doesn't have my footprint, or KiCad has a slightly wrong version of my footprint?
Okay, so I actually work on the KiCad libraries. And we have this wonderful tool called a footprint and 3D model generator, which you can use to basically put in data and get out footprints. So if you're missing something, in many, many cases, you can actually use that tool to generate it for you. But if it's not there, then it's a really useful and valuable skill to be able to make your own footprints. And this is a skill that, for some reason, like the payoff to effort ratio of this is so ridiculously good. And people are so afraid of doing it. Like, people literally pick parts for their projects based on what's in the library rather than draw a symbol and footprint. And don't be afraid, do it. Just take an existing footprint and modify it. It's not that hard.
Thank you.
Next question on number 1, please.
Yeah, curious if you have any suggestions, tips, ideas about dealing with the tariff situation for those of us that may have one to deal with. Specifically as relates to PCB manufacturing and how that's now ridiculously expensive.
Yeah. PCB manufacturing itself is not that heavily affected by tariffs. The biggest issues with that is importing some classes of components into the US. I can't really give you good advice for dealing with tariffs because it's going to be out of date next week anyway. The best advice I can give you is get rid of the fucker.
We're trying.
Next question on 4, please.
So I've ordered PCBs, but I forgot a stencil. Can you tell me which material I should laser cut to get a stencil, or is there a better way?
Okay, so there are places where you can order stencils separately. So you can still do that, even if you forgot the first time. But if you need a one-off stencil that you're never going to use again, you can actually laser cut it out of cardboard.
Thank you very much.
Next question on 3, please.
Well, will you hold any workshops here in the coming days?
Yes, though it's been a bit of a disaster because I fucked up and ordered some wrong parts. So I'm doing a workshop on day 3 and day 4. Sign-up lists will be up tomorrow morning, but I'm not going to do one on day 2. However, a friend of mine who designed a ridiculous thing has asked me to do a workshop helping people to build it. So my friend C. Presser built something called Stonehenge Soldering Challenge, which is a 1:1000 scale model of Stonehenge built out of electronic components. We have them at the hardware hacking area. We're doing a workshop today and probably tomorrow morning to replace the other one doing that. So yeah, definitely we're doing stuff.
Thank you.
Next question from the Signal Angel, please.
Yes. Hello? Hello? Yeah. There's one question from the internet, which is, I wonder if there's a reliable starting point you would recommend to the folks.
A reliable starting point for?
I guess for starting out with electronics and soldering.
Yeah, so this is a wide range of skills, and you can start basically anywhere. So you can start by taking devices apart. You can start by practicing to solder things. You can start by repairing things. Like there's many, many entry points, and you can build out from any of those. So start with whatever is most interesting to you at the moment, and then go from there, but don't stop.
I think it's also related to resources, like finding a spot, like a tutorial.
I don't really have a better answer to that.
Okay, we've got time left for 2 questions. Please let me see if the question is relevant for the whole audience or if it's a personal question. Okay, if it's for the whole audience, question 1.
I have a question about the people already being in the field and your experience about them. Do they want to welcome new people and just don't know how? Or are there a lot of people that don't really want the diversity in the field whatsoever? What's your experience?
So my experience is a lot of people would like more diversity but don't know how to reach it. There is like a cultural issue there, definitely, but like I don't think it's like we don't like diversity. We want to just keep doing it as it is. It's more like how do we get here from there?
Thank you.
Okay, short question from microphone 2.
Is there some easy way of actually selling things without going through all the certification steps? Because that seems like the hard part.
Yeah. So this is a difficult one to answer because the question is really like how much of a business do you want to run and how much do you want to build things? And if you're running a business, then there's a lot of things related to like formally running a business that you need to deal with, regardless of what you're actually building. And this is actually a big part of the hardware is hard meme, is actually running a business around hardware is quite difficult, as is running any kind of manufacturing business. Yeah, there's a lot of people who build things and sell them and just ignore all these things. I can't really recommend that, but lots of people get away with it.
Clement, many thanks for the great talks and the great insights we've got. Please tell us, where can we reach out for you in case the questions weren't answered?
Yes, please find me at the hardware hacking area.
So, a great applause for Clement. Many thanks.